Okay, so we're going to finish off this task. We're going to be looking at now with figures. Like we can represent polygons in a plane by listing the coordinates of its vertices as columns of a matrix. Right, so here we have this matrix which represents this triangle. So the way you want to set up your matrix is again using the coordinates of each of the vertices and writing them as vertical columns. Like so here A, here's the origin. A has coordinates 2, 3. Right, so horizontal component 2, vertical 3 to get to A. So this column represents vertex A. This 5, 7 represents vertex B. Right, so again, from the origin, we're going to go over 5, up 7. So again, here, this column represents vertex B. And this column represents vertex C, which has coordinates 6, 4. Right, from the origin, 6, 4. And we write it right, as a column. So here is, again, a matrix that represents this triangle. Right, so for the next couple problems here, it says we want to multiply this matrix, right, that represents this triangle ABC by the matrix found in question 2. So then we're going to interpret this product matrix as representing the coordinates of vertices of another triangle in the plane. Alright, so again, in problem number 2, we found this matrix, -1, 0, 0, 1. So we're going to take that matrix and we're going to multiply it by the matrix that represents the triangle. So now we've got to remember that when it comes to multiplying matrices, that the order does matter. Alright, so this triangle matrix has horizontal and vertical components, 2 by 3. Right, 2 rows by 3 columns. And we want to multiply it by this matrix, which is a 2 by 2. So again, remember when we're multiplying these, right, the order does matter. Alright, so we're going to have to multiply, write down the 2 by 2 first. Right, and then we're going to multiply it by the triangle matrix. And see what we end up with. Right. Again, we have to do it in this order because again, with the 2 by 2 and this 2 by 3, remember we need those inner dimensions to match in order for us to do the multiplication in that order. Okay, so let's go ahead and do row times column. So we do row times column. We're going to end up with our answer in the top right column, which would be a -2. So keep going. So top row, middle column. We do top row times middle column. We get an answer of -5. Alright, so I'm going to pause this video here right now, the recording, but I want you to continue on trying to find the rest of this matrix when we do, right, this 2 by 2 times the triangle matrix. Alright, so when you're done multiplying these two matrices, this is the resulting product matrix that you should come up with. Okay, so again, we're just doing row times column. These are the resulting matrix. So now what we're going to do is we're going to graph this matrix. Right? So again, we're looking at these as coordinates, but again, we're looking at them in terms of the columns. So we're going to graph -2, 3 first. So we go to the graph grid, go to -2, then up 3. I'm sorry, other way. -2, up 3. So there's that point. negative 2, 3. The next column is negative 5, 7. So from the origin, I'm going to go to negative 5 and up 1, 2, 3, 4, 5, 6, 7. And the last column is negative 6, 4. So negative 6, 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4. Alright, so when I graph those coordinates, connect them with a straight edge. I don't have my straight edge. Connect those. So what we see there is, since the question is, how is the new triangle related to the original triangle? Right, so as you can see, it's a reflection over the y-axis. Right, that's how these two are related. So this would be A prime, this is B prime, and this is C prime. Okay. So by taking the triangle matrix and multiplying it by this matrix, this 2 by 2, it results in us creating a reflection of the triangle over the y-axis. Which again shouldn't surprise us, because when we did number 2, right, this matrix was the matrix we used to help us get to do this reflection over the y-axis for the W matrix, right? So then this is a reflection over the y-axis. So you see that also works for, right, entire polygons. Alright, so I want you to pause the video, and I want you to be able to do problems 9 and 10. Alright, so 9, we're going to do, take that triangle matrix, an ABC triangle, and we want to rotate it 90 degrees counterclockwise using matrix multiplication. And then for number 10, you are going to take that ABC triangle and reflect it over the x-axis. Alright, so this is what you should come up with here. So again, we want to rotate this triangle 90 degrees counterclockwise. So again, from the earlier part of the task, that 90 degree counterclockwise rotation, right, we came up with this matrix, 0, negative 1, 1, 0, which got us to get that W matrix to rotate counterclockwise 90 degrees. So we're going to use that same matrix here, 0, negative 1, 1, 0, to multiply by the triangle matrix. Right, and as an end result, we get this matrix right here. Right, again, these are the coordinates for the rotated version of the triangle. Number 10, we want to take that ABC triangle and reflect it over the x-axis. So again, we're going to use this matrix, right, from earlier in the task. When we rotate over, when we reflect over the x-axis, we said that this was the matrix, 1, 0, 0, negative 1. That was the matrix that got us to reflect over the x-axis. So we're going to use that exact same matrix, 1, 0, 0, negative 1, 1, 0, 0, negative 1, to multiply it by the triangle matrix to come up with this matrix, which again, when we graph it, would represent the ABC triangle reflected over the x-axis. Okay. Alright, so that's it for today's video lesson. Your assignment is to complete the Ready, Set, Goes for 811. Alright, and that will be due on Wednesday. Alright, actually the end of the day on Tuesday. Alright, so you guys have a great day, and I'll see you tomorrow.